Hello everyone, welcome to IS 300, and this week we're talking about infrastructure security from the Cloud Security Alliance White Paper, Domain 7. In this week's discussion we will talk about the introduction to virtualization, an overview. Specifically we're talking about cloud virtualization, network virtualization, and how the security changes with cloud networking. We're talking primarily about infrastructure as a service. We're looking at the cloud compute model and workload security, and then ultimately at the end of the chapter we will talk about some recommendations. Infrastructure is the glue that all computers and all networks are built on. It is physical hardware. It includes the consumer's configuration, although they don't get to configure the actual hardware. They are configuring a virtual model of the hardware. And we also talk about the infrastructure components. In cloud computing, you have the resources that are used for building the cloud, creating the cloud. Those are the physical and logical assets, processor, memory, network, storage, all of the resources that are used by the provider to build a resource pool. Those resource pools are then used by a cloud consumer or a cloud user, and that includes network and storage assets that are derived from those resource pools. Every cloud implementation uses some form of virtual networking to abstract the physical network and create a resource pool. And keep in mind that virtualization simply means that you are using a subset of the resources that are provided, and you are able to, as a user, to configure and manage just those resources that are provided to certain users. There are three different types of networks in cloud virtualization. The management plane, which is of course the way to manage and configure and to monitor the network and all application programming interface traffic. Then you also have the storage network, which is virtual storage for virtual machines. This probably includes some sort of database or a subset of a database. And then the services between the virtual machines and the internet. There are two types of virtualization: virtual local area networks, or VLANs, or software-defined networks, which simply separates packets, control packets, from data packets. With cloud networking, you have physical appliances that cannot be changed by the user. They must be changed only by the cloud provider, which gives the user, means that the user must rely on the provider. And so virtual appliances can introduce bottlenecks. They might take some resources and degrade network performance. They should be able to auto scale, which means they can grow or increase or decrease as needed as the projects that are running on those networks increase and or decrease. They are movable between geographic locations or zones, and they may have a shorter lifespan because of the auto scaling, which means in some cases there may be virtual networks and virtual appliances that are no longer needed. Software-defined networks make isolation easier. You can create firewalls just as you can with hardware-based firewalls, but they are a little more flexible since they're not limited by a physical network topology. They can be single assets or groups of assets. You can segment those virtual network topologies into smaller, more isolated networks without any additional hardware. They can dramatically reduce the impact, the blast radius, if you will, if there is an attack, if there's a cybersecurity breach. The only portion of the network that will be breached is the portion that the hacker has access to, but not the whole network. So segmentation is a good thing, and it's based on software configurations as opposed to hardware configurations. For purposes of additional security and networking with cloud networks, the segregation and isolation in multi-tenant environments is critical, because if you have more than one user, more than one tenant, you don't want the tenants to have access to one tenant to have access to the other tenant's network. Sometimes the network can be compromised, and in that case, you have to make sure that there's no cross-pollination, or that the other users using the same cloud cannot be impacted by a breach of another tenant. Hybrid cloud considerations are only use hybrid clouds as needed, because hybrid connections can reduce the security of the network if the private network isn't at the same security level. And so hybrid connections should be avoided if at all possible. In some cases, it's unavoidable. In case of a disaster or an emergency, there may be a need to use a hybrid cloud, but for the most part, it is not recommended for day-to-day operations. You can break a virtual cloud network into workloads. A workload is simply a unit of processing, can be a virtual machine or a container. A container is simply an executable or a code snippet that can run independently. Containers or executables are platform dependent. They rely upon the software on which they're running. Every cloud workload has its own hardware stack, and maintaining the integrity of the stack is critical for the cloud provider and essential for the cloud consumer or the user. Platforms that run on shared machines that aren't virtual may be required in some cases. You can also have something called serverless computing, which means that the user doesn't manage any of the underlying hardware or virtual machines. They only manage their portion of the cloud network that has been allocated to them. The burden for maintaining isolation in workloads is on the cloud provider, and it must be one of their priorities. Cloud users do not get to control, or even may not even know, where the actual physical hardware is running or how it is configured. Container, simply an executable virtual execution environment that is isolated based on the operating system that manages the memory and the CPU, the kernel, if you will. Kernel, just another word for operating system. The container security will include the underlying physical infrastructure and the underlying operating system, and there will be an image that can then be used to allocate the network access to the provider by using a virtual container, and the security for that container, for that executable, for that portion that is assigned to the user, that security is built into the container. Immutable simply means it cannot be changed. So if you have a virtual machine, it is a machine that is not changeable by the user, but it can be auto-scaled. Instances can be shut down if they're no longer needed without breaking any of the underlying applications or the application stack. Patch management becomes more efficient because you can simply create a new image, a new gold master is what they call it in this chapter. A gold master can be re-imaged and redeployed without having to do the traditional patch management that we all know that sometimes falls through the cracks. Remote logins should be disabled. You can roll out updates pretty easy, and the testing should happen during the creation of the image itself. Agents that operate in cloud environments need to support dynamic cloud workloads, which means, again, they can auto-scale, they can increase or decrease as needed. Typically, you will have dynamically assigned IP addresses that can enable flexibility and or elasticity. File integrity can be monitored to make sure that any unapproved changes on virtual machine instances cannot occur. Dynamic IP addresses give more flexibility, but are a little more challenging for the cloud provider. The logs, security logs and monitoring, critical. And of course, if there is an auto-scaled instance, if that instance is lost, all of the monitoring is also lost. And so it's a good idea to collect the logs before a controller is shut down if it's no longer needed. Vulnerable assets need to be accounted for either architecturally and contractually. Service level agreements, which we will talk about in the next coming weeks, need to be very specific about what happens if there is a vulnerability and how those vulnerabilities will be addressed. Assessments should be done as the images are being created. Default deny is a recommendation that simply says deny everything unless it is explicitly allowed within the firewall. So you say no to everything except for the things that are specifically authorized. That is a good approach to reducing security breaches. Cloud firewalls should be applied on a workload basis as opposed to a network basis. Restrict the traffic in the workloads using a subnet. Subnet masking, just as you would in a traditional network, can be applied here. You can specify security groups whenever possible and minimize the use of virtual appliances to because they can have a tendency to increase bottlenecks. Leverage immutable workloads whenever possible. Make sure that the workload cannot be changed. Just upload the new image if necessary. Disable remote access. Be sure to test the images as they are being created. Make sure that there is monitoring and alarming so that if there is some unpredicted or unrecognized breach, it can be tracked and avoided at all costs. Update the image. Don't update the instance of a patch. So it's better to simply upload the new image with the patch updates rather than trying to update an instance of a virtual machine. Use tools that are cloud aware and make sure that vulnerability assessments and penetration testing has been handled and documented.